Ladies and gentlemen, we're about to begin, so please go ahead.
Thank you. Welcome, everyone, to today's Ziff Davis Enterprise web seminar, Tape Fallacies Exposed. The Future of Tape is Still Bright. I'm Sal Salamone, Executive Editor at Ziff Davis, and today we're going to be joined by David Hill, Principal of Masabi Group, LLC. Hi, David. How are you doing?
I'm fine, thank you. How are you today, Sal?
Very good. So I'm just going to go through a few housekeeping rules, and we're going to do a few poll questions, and then I'm going to hand it off to David. And as some of you know, David's a longtime industry analyst, and he specializes in storage and storage technology and strategies. So I think the presentation will be pretty valuable for those of you who have already joined us and those who are joining us now. For any of you who have not been attending these web seminars, these are fairly interactive events, so we'd like everyone to keep asking as many questions as they want throughout the presentation by hitting the Ask a Question button on your console. Additionally, if you really want to pay attention to the presentation and not be scribbling notes, the presentation will be available after. You'll be able to download it at the end of the talk. We'll have some time at the end for a Q&A. And before we get started, we wanted to launch our first of two polls, just to get everyone participating right off the bat. So we'll launch the first poll now. So which of the following best describes the data backup system in your storage environment? And please select one, disk-to-disk backup system, tape backup, a combination of disk-to-disk and tape backup systems, or none of the above. Now, to do this, you'll have to disable your pop-up blockers to participate in the poll questions. And we'll just take a second here for some of the poll results to come in. Okay. And now, why don't we push our second poll out? Which of the following best describes your use of tape both now and within the next year? And again, please just select one. Use tape within, you already use tape with increased, you expect increased use. You use tape now, but you expect decreased use. Use tape and the use will remain static over the next year. You don't use it and will begin to use it. You don't use tape and you don't anticipate using it. So again, we'll take a few seconds to let the polls come in. Okay. Now, as people are voting, we're going to now I want to just transition into our presentation today. And as I mentioned, we'll have some time at the end for questions. So please submit your questions throughout the presentation. And with that, I'd like to turn it over to David. Welcome again, David. Thanks for joining us.
Well, thank you very much. And thank you for everyone for attending today. The webinar on Tape Fallacies Exposed. The future of tape is still bright. Let's look at the agenda. The agenda is
There we go.
Good. Sorry for the delay. We're going to talk about, first of all, we're going to talk about a little stage setting, and then we'll introduce the three basic tape fallacies. But before we introduce the actual tape fallacies themselves, we have to talk some background, which gets into the areas of pooling, copying, and tiering. And then we'll address each of the three fallacies in order: the business use fallacy, the cost fallacy, and the manageability fallacy. Finally, we'll sum up with tape fallacies exposed in a nutshell, and then we'll turn it over to questions and answers.
Mm-hmm.
Okay. The critics, such as some analysts and journalists, have long proclaimed that tape is dead. Tape can take solace in the often quoted statement by Mark Twain that the reports of my death have been greatly exaggerated. However, the increased use of disk for backup and restore purposes has fueled those critics anew, and those critics have been aided and abetted by some vendors who, quite frankly, may have a bias in trying to kill tape simply to increase their own market share, and that is not necessarily in the best interest of their customers. Now, you may very well ask, where am I coming from as an industry analyst, especially since the paper on this subject as well as this webinar have been sponsored by the LTO program. Well, first of all, I have written what I think is a comprehensive book on data protection. If you should be so inclined as to read the book, I think that you will find a very balanced perspective, including a chapter on how disk and tape complement and compete with each other. Then, from a personal perspective, many years ago, I ran a Fortune 500 corporate data center, and even then we had 10,000 tapes in our tape library. I even mounted a reel-to-reel tape just to get a visceral feel of what it was all about. So my views in this webinar are consistent both with my writing and my real-world experience. The topic is relevant because otherwise IT organizations may make a mistake in their data protection, information, infrastructure, and investment decisions. Now we'll introduce the three primary tape fallacies. Although a whole laundry list of potential tape fallacies could be listed, basically they can be condensed into three primary categories, which are the business use, the cost, and the manageability fallacies. The theme of the business use fallacy is that disk can replace tape for all business purposes except perhaps for deep archiving. This might be called the anything you can do, I can do better fallacy. The reality is that the best strategy is typically a blend of disk and tape that addresses business, performance, and data protection objectives. The cost fallacy claims that disk solutions are competitive enough with tape so that there is no need to keep tape for economic reasons alone. The reality is quite different. Even if the costs were close, best practices for offline data protection still require tape. But the reality is that the cost of disk and tape is not even close. Research has shown that tape is significantly more cost-efficient than disk and that the gap will continue in the future. The manageability fallacy proclaims that, relative to disk, tape imposes an administrative burden because tape is unreliable as well as difficult and complicated to use. The reality is that today's tape drives and media, such as LTO technology, have proven to be highly reliable. Advances in tape automation, such as firmware, have dramatically simplified the management of tape storage. We need to understand where disk and tape are each best used. But before we do that, we have to come to a common understanding as to the different pools of data and different types of copies of data. A pool is a collection of data that is managed as a homogeneous whole for quality of service, that is QoS, purposes, such as all the data in the pool needs to have certain performance or availability characteristics. Pools of data fall into three primary categories: active changeable, active archive, and deep archive. A copy of each pool may be either a production copy, which means that it is the copy that is used as the active copy for real business use, or a data protection copy, which means that it is the copy from which a damaged or destroyed production copy can be restored. We will not consider test data as a third type of copy, as test copies are irrelevant for this analysis. Please note that the concepts of pools and copies are logical concepts and do not specify the physical medium, such as disk or tape, upon which they are implemented. An active changeable pool is what we usually think of as production data. It should consist only of data that is considered likely to change, such as an uncompleted transaction. In fact, much fixed content data, which is unlikely to change, such as old emails, may be commingled within the pool simply because there are no policies or processes to move them to an active archive. An active archive contains fixed content data, such as those old emails, which for whatever reason will need to still be accessible, either online or what is sometimes called nearline. A deep archive contains fixed content data that no one really wants to see again. Once again, some old emails, but may have to be retained for some reason, such as regulations preventing the deletion of the data. Note that the primary copy of the data, i.e., not the data protection copy, is still a production copy of the data as it is considered to be authorized, complete, and correct. and as a copy of the data. Now we'll move on to the storage pyramid and learn about tiering and pooling. Note that there is a mapping relationship between logical pools of storage and storage tiers, as seen in the figure, but they're not one and the same thing. Roughly speaking, Tier 0 is solid-state related, Tier 1 is high-performance disk, Tier 2 is capacity disk, and Tier 3 is tape. On the logical pool side, a slight variant is that offline means deep archiving, but nearline may be considered active archiving that has slower response time than what was typically considered online response time. Nearline is most likely on tape, but could be on capacity disk. Note that there are three variables, cost, capacity, and speed, that tend to map to the different storage tiers. For example, SSDs are much faster than tape, but also tend to have less capacity and are more costly. Note that the three variables do not imply what is best, as there may be other variables that have to be considered. However, if high performance is a mandate, the cost of SSDs may very well be justified. On the other hand, where the performance of tape is satisfactory for a particular application, paying a premium for SSDs, even if SSDs could do the job for other reasons as well, would not seem to be a reasonable choice. Still, even for the production copy of the logical storage pool, which is what is represented here, tape would seem to have a role, not only for the offline storage of deep archiving, but also a role in the nearline area of active archiving. Now, one might say, what happens if a piece of data on nearline, say an interview of Michael Jackson, needs to be accessed repeatedly? Why, then it can be moved up tiers, perhaps even to Tier 0, which can then act as a disk cache. So don't rule out tape even for production use. Finally, we can address the business use fallacy that says that the only possible use of tape might be in deep archiving. In fact, let's work backwards from deep archiving. Tape seems the best choice for deep archiving for such reasons as the ability to transport data to a third site, and for I/O isolation. I/O isolation means that electronic altering of the information is not possible. Disk, such as MAID, which stands for Massive Array of Idle Disks, and multiple hop electronic vaulting are possible, but those solutions would seem to be a bit convoluted at this time. We have seen in the previous slide where tape may play a role in the production copy of an active archive, but disk will continue to play its customary role where true online access is required. On the data protection side, disk would be needed if fast failover is required. However, tape would be acceptable if slower recovery is acceptable. Tape might be the choice for other than the first backup copy, following the same principles that would be used for active changeable data protection copies, which we will now discuss. On the active changeable production copy side of the house, disk is the obvious choice because of the expected need for random access to the data for creating, reading, and updating data. However, on the data protection copy side of the house, the choice between disk and tape is not necessarily obvious. One reason that the choice is not obvious is that there are multiple data protection copies, not just one. Each copy forms a layer or degree of data protection. Best practices, as described in my book on data protection, require a minimum, repeat, minimum of 3 layers, i.e. data protection copies. These might be called the first, second, and last lines of defense. Let's look into these lines of defense in more detail. Although a production copy of data on disk can also have some data protection characteristics, such as RAID or snapshot copies, a separate physical non-production copy of the data is considered the first line of defense. That line of defense is for operational recovery, or also could be called OR. Operational recovery deals with day-to-day incidents rather than disaster recovery, which can also be called DR, which deals with, hopefully, extremely rare events that require failover to a remote site. Consequently, OR, or Operational Recovery, deals with local site incidents. These incidents tend to be not for physical problems, but rather for logical problems. For example, the physical failure of a disk array is a rare event, as at worst a single disk can be rebuilt if RAID is used, in the sense that the whole array has to be restored from a data protection copy. However, logical data protection problems are more likely. Logical data protection problems include the accidental deletion of a document, a virus, a hacker attack, or database corruption. Anything where non-physical changes and switching bits from 1 to 0 and vice versa does not really count as a physical change have been made that turn out to be undesirable. Note that the restoration may be only for a single document or all the data used by a single application rather than a full restoration. Although time to restore may or may not be an issue, the operational recovery copy may be made by backup software. The issue may be whether or not there is time to run the backup job. That is the running out of night problem. The use of disk as a target for the first backup copy, such as the use of a virtual tape library, may very well solve this problem. However, don't automatically throw disk at a backup window problem. Moving fixed content data that has been unnecessarily stuck in an active changeable pool of data to an active archive pool may reduce the time pressures on the backup process. So although in many situations a good case can be made for disk as the first line of defense, even here clear thinking is needed because an existing tape solution may still be satisfactory. The second line of defense is for disaster recovery, DR. DR requires a remote site that can be failed over to in the event of a true disaster, such as a hurricane or an earthquake. Remote mirroring can be used for physical data protection, but may be restricted to only time-critical data because of the cost. Remote mirroring is only good for physical data protection. Any logical data corruption at the local site will be quickly propagated to the remote site. An alternative is electronic off-site faulting of data from disk at one site to disk at another site, which provides both physical and logical data protection, assuming that the original data was not unknowingly corrupted at the time of the copy. Bandwidth issues aside, that is likely to be an approach that is going to grow in popularity. However, the question is whether the data is in native or non-native format. Native format, such as copying a snapshot, means that the data at the disk array at the remote site should be able to be used by applications without any requirement for data restoration. That is great, but the cost for the solution must be calculated and processes put in place to put it in place. The alternative is non-native format, which is typically a tape format, even on disk, which requires the data to be restored to a disk array. However, writing in a non-native format is what backup software does, and familiarity and ease of use go a long way, especially in a disaster. If the data is written to disk, that requires an extra array. If tape is needed anyway, say as a last line of defense, then the only reason for the extra array would be for speed of restoration. However, in a true disaster, normal service level requirements are thrown out the window, and there is usually time to restore from tape. And if that is the case, the tried and true technique of restoring from tape sent off-site to a third party may be satisfactory. Yes, that involves manual work in transporting tape, but guess what? That has been done, mostly successfully, for many years. Some things to note about the last line of defense. The first is that this represents the last chance to get your data back. The implication is that all those other attempts have failed for one reason or another. That means that the DR information could not be used to restore an operational recovery copy, even if the problem was only a local problem, such as multiple nearly simultaneous disk failures, causing the inability to use all the data in an array. That finding leads to some important implications. If the data is lost permanently, all the investment in data protection was wasted. Therefore, the ability to be able to restore the information is the primary concern, and that the data must be safe, complete, and accurate. That leads to the point that data preservation trumps data availability, and that lack of availability may have its costs, but nothing is compared to never being able to get the data back at all. Safety, in the sense that the data is uncorrupted, both physically and logically, is paramount. Logical data protection requires some form of I/O isolation, where no unauthorized I/O changes, whether from external or internal sources, is possible. Although the last copy may be at a disaster recovery site, what happens if that site is destroyed? Do you really want the operational recovery copy at the local site to be your last line of defense? The case for having the data at a secure third party can be made. That is important for the flexibility that may need to be taken to restore to a third site if necessary. All that speaks to the point that tape is the logical choice. If disk is used for all three minimum lines of defense, then 3 arrays have to be used, at least one locally and one remote, as well as an extra one either locally or remote. And, as just discussed, if the site with the 2 arrays is destroyed, then you are back to having only one layer of data protection, and that without I/O isolation. Flexibility makes tape the wise choice. We've been talking about the last line of defense as the third line of defense. Now there is, of course, an ultimate last line of defense, but you hope never to get there. One way of doing this is to have extra layers of defense. The reason is that you never really want to get down to your last line of defense. After all, think of the stress that this would entail to get it right. You hope never to have to use the third line of defense. But if physical or process problems arise, you still want to know that you have another chance. How many you choose is up to you, but many organizations have 4 or even more lines of defense. The more lines of defense speak to the use of tape over disk. Remember that a layer of defense is a complete physical copy of the data. You can leverage your tape automation investment, including tape drives, to produce copies on tape media. The same is not true for disk. You have to have a physical array for each copy of the data. Now, there has been a great deal of talk about data deduplication using disk-to-disk backups, such as using a virtual tape library, or VTL. That is useful in extending how far back in time you can save data on disk for restoration purposes. But remember, all that data is simply one physical copy of the data, and that means one and only one layer of data protection. If you want an additional layer, that would be another disk array. So tape seems to be the clear winner. For the first line of defense, disk has grown in popularity for performance and availability reasons. That does not mean that tape should be dismissed out of hand. The environment and circumstances should be examined carefully. The same is true for the second line of defense for disaster recovery. Disk can play a prominent role where availability, even after a major disaster, is critical. But does that mean that all the data needs to have that same level of availability? And tape may have an important role in protecting that type of data. An IT organization should carefully examine where it makes sense to use disk and where it makes sense to use tape. For the other lines of defense, especially the last line or lines of defense, tape would seem to be the clear choice for the reasons discussed earlier. The use of disk is not impossible, but the cost of that solution and the inflexibility that it would provide would have to be carefully examined. So tape seems to be the clear choice.
And now as the next slide is loading, I just wanted to jump in, David, for 1 second. Just remind people, please keep submitting your questions. We've got a number of good ones already. We'll have a time at the end we'll have a Q&A session at the end, and we'll be going over the poll results then too. So back to you, David.
Thank you. Let's go back to the figure on where tape and disk are each best used. This addresses the business use fallacy where disk is purported to be able to replace tape for most practical purposes, with the possible exception of deep archiving. We have seen that this is simply not true. Tape is likely to continue to play a role in each of the principal pools of data, active changeable, active archive, and deep archiving. Now that the business use fallacy has been exposed for the fallacy that it is, let us turn our attention to the cost fallacy. Cost considerations are never far from the mind of an IT manager in these difficult economic times. A disk solution may not have to be exactly equal to a tape solution, but if disk is going to replace tape, money talks. And so the fallacy states that disk solutions are cost competitive enough with tape solutions that there is no need to keep tape for economic reasons alone. If that were true, then the assumption is made that disk is a superior product and that a superior product drives an inferior product out of the market. However, that argument suffers from two delusions. The first is that the assumption that disk is a superior product. Yes, disk and tape have different characteristics, but there are different horses for different courses. We've already seen that tape has certain characteristics, such as I/O isolation and transportability, that make it best for certain situations, and that disk has certain characteristics, such as random access, that make it best in some other situations. But differences do not mean that one product is superior or inferior to another. The second delusion is that one technology will replace another. Yes, there are no significant buggy whip manufacturers left, and vacuum tubes are probably a niche market at best. Yet radio is still around despite TV. In the IT field, mainframes are still around and going strong, although, like tape, the death of the mainframe has been long predicted. Then there is the question of cost comparisons between disk and tape. On the surface, a disk array with SATA drives might seem to compare favorably with a tape library with tape drives. However, let us examine the facts. In February 2008, friends of mine at the Clipper Group, which is an industry analyst firm, published a paper on disk and tape squaring off again in one of their Clipper Notes publications. A Clipper Notes paper provides vendor-agnostic explanations and advice for the information technology buyer. This paper explored the cost economics of disk versus tape in detail with numbers. The result, in my opinion, was shocking and surprising. Based on previous works that I have seen in the past, I suspected the cost of a tape solution would be more favorable than that of a disk solution. What I was not prepared for was that they showed that for a mid-sized enterprise, a tape solution had a significant, which means greater than an order of magnitude advantage over a disk solution for the cost of a terabyte of data stored on tape as compared to being stored on SATA disk. And they even took data deduplication into consideration. I won't steal their thunder, but instead suggest that you read their document thoroughly. I suspect that even if you were to tweak the numbers as much as you could, the basic premise will still prevail. The first point is that pure acquisition cost favors tape. That is important because that represents out-of-pocket direct costs to buy. If one or two alternatives is more expensive in terms of acquisition costs, it can still win on a total cost of ownership, that is a TCO, basis over, say, 5 years, if other costs such as maintenance, floor space, and energy costs can more than offset the difference in the acquisition costs of the two products. Sorry, tape wins on all fronts. The implication then is that tape shouldn't have to justify its existence, but disk does. Now, obviously, disk is important and here to stay. I'm not saying that. However, in situations where tape and disk can both work from a technical perspective, disks must offer something that is not in the pure cost analyses, such as being able to reduce the size of the backup window. A value has to be assigned to whatever disk can do better. That value has to at least offset the increased cost of a disk solution. The conclusion is that replacing an existing tape solution may be hard to justify. And as you can see from the Fleischman-Hillard survey, many who have disk-only systems are starting to use tape again. The cost fallacy has been dismissed. A number of accusations can be thrown against tape to disparage it, including that tape is seen as unreliable, as well as being difficult and complicated to use. There are two responses to these accusations. The first is a technical argument that is rooted in the physical characteristics of a tape solution. The second argument looks at the need to have the proper people and processes in place. Let's take a look at the tape technology response first. A tape solution involves the fascinating interplay of the robotics in the tape library with tape drives and tape media. And yes, each of these three components as electromechanical elements can fail. For tape media, that could be the failure to be able to be read. For a tape drive, that could be the inability to ingest or eject a cartridge. And for a tape library, that could be the inability of the robotics to move a tape. However, today's tape automation libraries have sophisticated firmware and utilities that can simplify and add flexibility to tape management, including logical partitioning, drive pooling, and tape health metrics. Yet a lot of failures are as the result of degrading performance over time, rather than sudden total failures. Rather than waiting until an actual failure occurs, which is reactive management, having the information available to take corrective action prior to a service level impacting event actually occurring, and then acting on that information is important. That is proactive management. And unlike what may have been available in the past, proactive management is now available for use with tape technology. Take media, for example. For example, all generations of LTO technology use read after write verification to make sure that the data is able to be retrieved. This is instant feedback that the data will be readable when retrieved. Now, one might argue that this is still no guarantee, but since tape media is a fairly stable media over time, that should solve the vast majority of the readability problems. Then there's the cartridge memory chip in each LTO cartridge that contains historical information about the cartridge, such as the numbers and types of records with errors, the number of loads, and the age of the cartridge. Analytical tools can use that information to give health scores so that a piece of media can be replaced before a service level impacting event actually occurs. On the tape library and tape drive side, some tools are available for such things as workload balancing and alert management. So today's tape technology has a lot going for it as far as manageability tools as compared to generations past. Let's sum up with an example. With the usual caveat that your mileage may vary, you can see from the quotation that Dick Cosby is a happy tape user. Dick Cosby is a system administrator at EDPS, which is the IT department for a large trucking company. Dick has very good reason to be fond of tape. He was able to use tape to recover his company's data after a true disaster when a hurricane flooded his data center. Now his company has a remote disaster recovery site that uses disk and tape, but tape still plays an important role for EDPS, and Dick would not be without it. I have a saying, if you don't know how to do a task right, then that task is very difficult or impossible. If you know how to do a task right, that task may seem quite easy. I once wanted to do something in PowerPoint one time, but just couldn't figure out how to do it, even though I had seen the functionality used in a number of presentations. In frustration, I vocalized my problem, and somebody called out, "It's simple, all you do is," and that person was right. The same may be true with a tape solution. If it is done right, it could be easy. Take, for example, the intricate relationship that backup to tape has with backup software. For example, improving the backup window may be a matter of making sure that all tape drives are working in a balanced fashion. Even such things as planning to have enough pieces of media available can avoid problems. So it really gets down to making sure that the right people and processes are in place to manage both disk and tape solutions. All the potential in something like cartridge memory will do no good if people are not training in what it is and understand what it can do for them. Then that knowledge has to be embedded in policies, processes, practices, and procedures that ensure that the knowledge is put to good use. Having all the information and the tools to manage it comes to naught if there is no knowledge of what it means and no execution on a daily basis. All in all, disk and tape are different, but don't mistake differences for manageability. Both have to be managed correctly. sum things up, you can see the tape fallacies exposed in a nutshell. You can read the slide for yourself, so we won't go over each item in detail. But I want to remind you once again why this is relevant. As an analyst, vendors sometimes send me things in the mail. What was in a small box I received recently was a small placard or notice. I really don't know what to call it. On it was pictured a tombstone on which was inscribed, "Tape Backup, 1951 to 2009. Rest in peace." Obviously, it was from a disk-based backup vendor. A little literature talked about faster backup window, scalability, and ease of setup and use. All those are nice, but they beg the question, how can you justify totally replacing a tape solution? Having only a hammer to resolve backup and data protection issues may be short-sighted. Having multiple tools, i.e. disk and tape, in the toolbox could be the optimal approach for you to address your performance, long-term retention, data protection, and cost objectives. Now we'll move on to questions and answers.
David, thank you so much. That was great. And just as an aside, I also have that tombstone sitting on my desk. It's apparently a refrigerator magnet or something like that from the vendor, yes.
I didn't want it too close to any of my electronic equipment.
Yes. So, well, this was great. Very useful information. And we have a number of questions that have come in. And before we get to them, I thought we could go through the poll results because there's some interesting, people. Why don't we just look at them, and I'd love to get your opinion on them. So, just as a reminder, the first poll question was, which of the following best describes the data backup system in your storage environment? And we've got the results projected there. So, about 15% have disk-to-disk only. About a third have tape backup, and then a combination of the majority or the largest percent have a mix. So, David, does this jive with what you're seeing out there?
Yeah, I think it is. What it indicates is that most people still have a combination of disk and tape, but also still have tape backup. What's interesting to me is that those who were listening in on the conversation today on this backup only must wonder why, must be interested in understanding why tape is important again.
Mm-hmm. Okay. And now why don't we go to poll 2. And just a reminder again, that was which of the following best describes your use of tape both now and within the next year? So so again, let's see. We've got interesting here. Many use tape and the use will remain static. Was almost a little under half of the voters. Only a few are decreasing. About a fifth said they would decrease its use. Again, does this jive with what you're seeing?
Yeah, well, I think there's some more increase in disk-based backup, so that's why some useful there. But it's also interesting to note that use tape will increase its use is important as well.
Yes.
And but almost the half are still using tape, and still will remain. The use will remain stable as such. Okay. But it's also interesting to note there's a small fraction that will actually begin to use tape. So that's interesting.
Yeah. All right. Well, why don't we get to some of our questions? And we probably won't get to all the questions. Those that we don't get to during this session, somebody will contact you after with the response. So, why don't we start with? Do you see any new uses for tape as more features are incorporated?
Yeah. Yes, indeed. New and expanded use. Tape is becoming the medium of choice for long-term retention in a number of industries, such as the rich media segment, including media and entertainment. And it is a good choice for the medical industry for long-term retention of medical records, X-rays, and the like. For example, it's being used for storage by law management, for video monitoring on patrol vehicles and parks and other areas. Tape role for backup, archive, and data protection will continue. And that, one of the reasons, by the way, is that a lot of that information doesn't have to be restored instantaneously.
Right.
You can get it back in a minute or two, and it's perfectly fine. And then it's on disk and it can be used. But disk is used as a cache in that sense. So I think there's a real place for increased use of tape.
All right. Here's another one. Do you see solid-state memory as an eventual replacement for disk with tape as a cost-effective deep archive solution?
As discussed, an offline copy of data is needed as one of the lines of defense against online threats, like a system error, human error, virus sabotage, or even a disgruntled employee. Tape is the best offline storage today and for the foreseeable future. However, within tape, disk will still be around, and so you have a combination, I think, probably of high-performance disk, which will be probably solid-state disk, and then capacity disk, which will probably be a SATA disk for things that don't require the same performance levels. So you have a combination of the two, as well as tape.
All right. Here's another one. What are the pros and cons of using data deduplication for deep archiving? That's
actually an important question because it's understanding that archiving is extremely critical. Archiving is different than backup. Backup is a temporary saving of data in the event it is needed for production recall purposes. Archiving is saving a single copy of data with the expectation that it will rarely or never have to be used again, but it must be retained just in case, probably for internal or external compliance policies, for example. Data deduplication is a benefit of eliminating redundant data can only take effect after several cycles of backing up data occur when it's been saved, and has to be used in multiple. It can then be used in multiple subsequent comparisons. It can then eliminate the redundancies over time. In other words, if you're running a backup, you run it many times, and then you can take out the water, so to speak. Since the archive, however, is a single instance of the data, dedupe does not have a chance to do the redundancy process. Therefore, dedupe is not needed for data archives. So it's irrelevant. Data duplication is irrelevant in an archive then.
Okay. This is a pretty general question, and I think you covered it, but somebody's just asking again, what role does tape play in data protection?
What role does tape play in data protection? Okay. We talked. That's what the whole session was about. I mean, the first, second, and third lines of defense. Okay, where it appropriately plays, and it obviously plays a role in the last lines of defense. Can very well play a role in the disaster recovery side of the house, and can possibly, in a lot of cases, can still play a role even in the first lines of defense for organizations, especially smaller organizations that are using tape today. And can't afford a huge investment in extra equipment. It may be perfectly satisfactory for them to use tape.
All right. We're running out of time, so I was wondering, if you want to summarize today, what's the one key takeaway you want people to leave with from today's talk?
Well, when you talk about technology, the thing is that a lot of times people get very excited about the new technology and that will replace an older technology, okay? And that's not necessarily the case. It may change how the older technology is used, but the older technology is still likely to have some benefits and use in a lot of different areas. And I think that's extremely important. So I think that's where we're trying to get to today, that the tape is not only dead, it still is good for data protection. Moreover, we already talked about it can also be used in other things that other than just data protection. It can actually be used in archiving in a lot of cases. So, tape is here to stay.
All right. Well, thank you. This has been very great. I really appreciate you taking the time out today. We have your contact information up on the screen if people wanted to follow up with you. For the questions we couldn't get to, somebody will reply after the web seminar. I just wanted to thank everybody for joining us today in the audience. I know your time's precious, so thank you for participating. Thank you, David, for taking the time. And thank you for our sponsor, the LTO program. And just as a reminder before you leave, you can download a copy of today's presentation. There'll also be an exit survey. If you can please fill that out, we appreciate it. We really like your feedback so we can fine-tune these web seminars. If you want to see what else we're working on in terms of presentations, you can look at our calendar at the eSeminars Live website. And also, this seminar will be archived shortly, and again, you can view it on the eSeminars Live website. So again, thank you for everyone. Thank you to our sponsor, the LTO program, and thank you, David, for your presentation.
Thank you.